Students, this is the help video for the ALEKS portion of the take-home practice quiz 3.1 to 3.4. Taking a look here, I've given you sample problems for ALEKS. You can do as many of these or as few as you choose to. This is a sample for problem number 2. You are told that L and M are parallel, so you want to always trace and stretch out parallel lines. Arrow feathers. Now, the minute you know something's parallel, you should be watching out for armpits of the Z. So we take a look here. Armpit of the Z. And we know whatever that angle is, we can bring it down over here. We're like, but there's nothing there. So not only do you want to watch out for armpits of the Z, you also want to watch out for linear pairs, which tend to get overlooked. So this is 180. And of course, to get that blue angle, that's going to be 180 minus the 132. And we get here 48. Armpits of the Z, this is 48. There's a couple ways you can solve this. You could get this angle here, and you would get armpits of the Z. Because triangles add up to 180, that would be one way. You could work that orange triangle, or you could work this linear pair here again. Actually, it's not a linear pair, but it's still 180. But either way, it's going to be the same mechanics here. It's going to be 93 plus 48. And you take that away from 180. You're going to get 39 degrees. So X would equal 39 degrees here. Problem number 3, use the markings to determine things that are true here. Taking a look at number 1. All right, so you take a look at this first one here, and you're like, how could I find the measure of angle M? That's what that little m means, measure of angle M, when there's no numbers there. So you need to be a little observative. Notice, if all 3 sides are equal, then all 3 angles are equal, which would make this 180 divided by 3, and therefore all 3 are equal. Looking over here on the right, it wants you to find the measure of angle Q. Again, there's nothing there. But you always ask yourself, what is there? And we have 2 equal sides. If you have 2 equal sides, you have 2 equal angles. We'll call them both x. So we know that x plus this 40 here has to equal 180. So we get the measure of angle Q is 70. It wants you to find just the value of x here, but as I've told you before, always just attempt to find everything possible, and then you'll just kind of stumble across the correct answer, which is x. So looking here, two equal sides, two equal angles. 71, that's 71. And of course that adds up to 142. Take it away from 180. And we get 38. You're like, what else can I find? Well, that is 90 degrees. So 90 minus 38. 52. And you're like, how else can I find stuff? Over here, 2 equal sides, 2 equal angles. So if that's x, that's x. So I have x plus, now it's just like the other problem, 52 equals 180. So we find both of these angles are 64, and you have solved for x. Taking a look here, we're finding the measure of each degree angle. We are told DEF is isosceles, hatch marks, and angle E is 5x plus 39. Angle F is this. It's asking you to find the degree measure of each angle. We're going to do a thing equation first. And our thing equation is angle plus angle plus angle equals 180. And I take a look here. My one angle, this is 5x plus 39. This angle here, my first one, is going to be 2x plus 30. And you're like, wait, there's nothing here. But remember, if it's isosceles, 2 equal sides, 2 equal angles. So this is also 2x plus 30. And we solve. That's 2x, 2x, 5x, that's going to be 9x. That's 30 and 30 and 60 plus 39, that's 99 equals 180 minus 99. And we have 9x. 90 would make that 90. And then minus 9 would make that 81. Divide by 9x equals 9. You're not done because it wants the degree measure of each angle. So we come down here. 2 times 9 is 18 plus 30. That's 48, which makes this 48. And then 5 times 9 is 45 plus 39. Makes that 84. And if you really want to check this, you simply add 84, 48, 48. That's 12. That's 20. Carry the 2. That's 10. That's 18. 180. Check. It's asking what each of these segments are, and let's just define them. That's probably the easiest. A perpendicular bisector is a segment that is perpendicular and bisects. That is a perpendicular bisector. A median goes from vertex to the opposite midpoint. That would be a median. Angle bisector, I'm using the same segment for all of them. Angle bisector bisects the angle. That's an angle bisector. And then altitude goes from vertex, right angle, opposite side. That's an altitude. So coming over here, matching this up, this first one is a right angle, boom. So that would be a perpendicular bisector. This one, it bisects the angles, so it is an angle bisector of H. This one, it goes to the midpoint of M, so that would make this a median. We are told that these three segments, JN, KP, and LM, are all medians, and they meet at a single point, Q, which means Q is a centroid. Knowing that, we know Q to P is 12. Immediately, once you know a little piece of information, you should start figuring this out. Here is a 2-to-1 ratio, so that that's 12. That's 2 bunny hops. That's 12. That's 12. Q to M is 11, which means 2 bunny hops here. That's 11. That's 11. And J to N all the way is 27, and we have a 1 bunny hop, 2 bunny hop scenario there. So once you have everything scoped out and labeled, it's really easy to answer these questions. J to Q, J to Q, right here. 27 is the whole thing, and it is 3 bunny hops. So we simply do 27 divided by 3 gets you 9, and J to Q is 2 of those bunny hops, so it is 18. K to Q, right here, we already have, is 12 and 12, that's 24. L to M, L all the way to M is 3 bunny hops, 11 each, that's 33. Taking a look here, we have a triangle below. Step number 1. We're told that XYZ has vertices of 7, -4, 1, -8, and -1, 6. We're going to find R is the midpoint of XY. So we're going to find the midpoint going this way and labeling that R. And S is the midpoint of XZ, so S is the midpoint going this way. That's S. So we're going to have to find the midpoints of each of these. So step number 1, add the X's, divide by 2, add the Y's, divide by 2, add the X's, divide by 2, add the Y's, divide by 2. Working the blue side first, add the X's, that's -7 and 1, -4 and -8. Going this way, that's -7, -1, and -4 and +6. We find those midpoints. -7 plus 1 is -6 divided by 2. That would give us -3. That's -12. And divided by 2 is -6. So my midpoint for R is -3, -6, which if you graph it, right here, -3, 1, 2, 3, -6, boom, it actually looks like the midpoint. And then S, that's -4 divided by 2. That's, -8 divided by 2 is -4. That's 2 over 2, that's 1. And so my S has to sit at -4, +1. -4, +1 is our S. Now we're going to take these midpoints. We're going to come over here. We're going to do something with these midpoints. So we have here R is at -3, -6, and S is at -4, +1. Says it wants you to find the following lengths. We want to find RS, length, and then we're going to find YZ, length. Says exact terms, which means you're going to leave it under the radical sign. You're going to find the distance equation. Well, you're going to give your exact in simplest form, so we'll do this. There's RS, and then here we have YZ. Whoops. These are minuses in the middle here. Minus, minus, minus. Okay, let's do RS first. -4, -3. Notice I'm using arrows to keep track of my direction so I don't make a mistake. You don't want to make a mistake here because then you have to redo the entire problem. And double negative makes a positive here, so that's -4 plus 3, that's -1 squared, plus, and then here we have 1 minus 6. That's going to be -5 squared. We end up with 1 plus 25. So we're going to get here, RS is going to be square root of 26. Ta-da! Okay, you can't factor 26 because if you factor it, it's just 2 and 13. They're both prime, so that stays root 26. This ends up being -2 squared plus double negative makes a positive 14 squared. I dropped a negative here. Up here, got to be really careful. That's -6. So this ends up being 1 and double negative makes a positive. That's going to be 49. So this is right here, friends. That's going to be square root of 50, which is 5 root 2. This is going to be 4 plus 196 square root. That's square root of 200. And that ends up reducing to 10 root 2. So what we've proven here is one is double of the other. Word to the wise, watch out for those double negatives. So right here, the slope, we're going to find the slope of both of these. Once again, make sure your coordinates are very accurate. You don't want to have to do this twice. -3, -6, -4, 1. Okay, so we find the slope of RS and the slope of YZ. So in red, y minus y. Make sure you get the y's on top. That's going to be 1 minus -6. And it's going to be -4 minus -3. My slope here, double negative makes a positive. That's 7 over double negative makes a positive -1. So it's -7 over 1. This one is going to be 6 y minus I, that's -8, -1, and +1. This is 14 over -2, which is also -7 over 1. Okay, so we have proven that the slopes are equal. So math has meaning. Because we started with the midpoints, and then we found the length of the segments, and we're describing the relationship of the midseg to the longer seg. Realize, lengthwise, that was 5 root 2 compared to 10 root 2. So comparing the shorter to the longer, we know that the segment that joins the midpoint of the two sides is half the length of the third side. Down here, the segment that joins, the slope was -7/1, and the other was -7/1, which means if the slopes are equal, it is parallel. So we have proven mathematically that this mid-segment, first it's a mid-segment because it connects the midpoints. Then we compared the lengths, and the lengths were 5 root 2 and 10 root 2. One is half of the other, and then the slopes were -7/1, -7/1. Therefore, they are parallel.